Right. So can you guys see my screen now?
Yes, sir.
Okay. So for this module, we'll discuss about the language of relations and functions. So last meeting, we've discussed the language of sets. So you've learned about subsets and proper subsets. And then for today, you're going to learn the other sets or the other types of sets. Okay. So without a further delay, let's start. So as you can see right here, we have an empty set or a null set. So from the name itself, very straightforward. So it is a set which does not contain any element is called an empty set, or the null set or the void set, and it is denoted by V. Okay, so if you see this symbol, meaning that set doesn't have an element. Okay, so in roster form, V is denoted by like this: a set contains nothing. Okay, an empty set is a finite set, of course. Of course, you can count it since it doesn't have anything. Okay? Since the number of elements in an empty set is finite. Like for example, 0 or 0 elements. So for example, the set of whole numbers less than 0. Okay, so this is a set wherein our condition is it is a set of whole numbers less than 0. And if you're going to take a look on this one, whole numbers is composed of 0 and then positive onwards. So you could say that this set contains nothing, or an empty set, or a null set, or a void set. Okay, so those three are just the same. So clearly, there is no whole number less than 0. So therefore, it is an empty set. Okay, so very straightforward. If it's empty set, null set, or void set, meaning doesn't have a count of elements. Okay, contains nothing, empty. Okay, so moving on, we have here a further examples when it comes to empty set. So let's say we have natural numbers. Okay, x is an element of natural numbers. Okay, ranging from greater than 3 and then less than 4. Okay, so we have here a set A wherein it contains element ranging from 2 to 3, okay, or greater than 2, less than 3. So x is a natural number. So what are the natural numbers again? Guys, what are the natural numbers? Anyone who can recall? So other one is whole number. So when I say whole number, it is 0 and then positive onwards. How about natural numbers? What are those numbers?
1, 2, 3.
Wala? All right, so natural numbers are 1 onwards or 1 to positive onwards. Okay, so titignan nyo to. The only difference between whole numbers and natural numbers is 0. Okay, so in natural numbers, we will start in 1. But for whole numbers, 0 is counted. Okay, so in here, you could say that uh, A is an empty set because there is no natural number between 2 and 3. So the only numbers that exist between 2 and 3 are rational numbers. Okay, 2.5, 2.1. So it has a decimal. So in this case, since our condition is natural number, so there is no number between 2 and 3. That is natural number. Okay. So another example is let P as a set, and then it has an element of composite number less than 4. So kung hindi mo alam yung meaning ng composite number, I've prepared a definition here. So a composite number is a positive integer that can be formed by multiplying two smaller positive integers. Equivalently, it is a positive integer that has at least one divisor other than 1 and itself. Okay. So what are those numbers? So actually mag-start tayo sa 6. Okay? That is a composite number. It has a dividend by 2, okay? Or dividend by 3. And even 5 actually. No, sorry. 5 is not included since it's only it can be only divided by itself and by 1. But for 6, you can divide it by 3 or by 2. Okay. So 4, you can only divide it by itself and by 2. X is a composite number less than 4. Yeah. So this one is less than 4. So we will not consider 4, but 3 and below. Okay. So 3 can be only divided by itself and by 1. The same with 2. It can only be divided by itself and by 1. And the same with 1. So it can be only divided by 1 and of course itself, which is 1. So we could say that B is an empty set because there is no composite number less than 4. Okay. So this is another example of empty set. So just take note that P is not equal to a set which has an element of 0. So this one is not an empty set anymore. Okay. So this one is a set which has one element, namely 0. So this is a number. This is already an element. Okay. So the cardinal number of an empty set is 0. So when we say cardinal number, it is a count of elements of inside of that set. So in this case, we have one element. So this is not empty set anymore. But this one, P symbolizes the empty or the null or the void. So this one doesn't have a count of elements. But for this one, we have one count of elements. Okay. Are we clear so far until this point? Are you guys getting the idea of empty set or null set?
Yes, sir.
All right. So again, empty set or null set or void set are just the same. So all of them doesn't have an element inside of that set. Okay. So moving on, we have singleton set. Okay. So this one is also very straightforward. So when you say singleton, it contains one element only. Okay. Strictly one element. If it's 2 and above, then that is not singleton set already. Okay, so it is a set which contains only one element. It's called singleton set. So we have an example here. For example, A is a set wherein it has an element of neither prime nor composite. Okay, so it is a singleton set containing one element, one, because this one is not, uh, yeah, not a prime number and not also a composite. I see. Okay. So this one is not actually included in composite number. Okay, but if you're going to take a look on this one is under the characteristic of composite number because this one can be only divided by itself and by one, which is of course the same one. This one is not under composite. Of course, neither prime. Okay, so if you don't know the meaning of a prime number, I've also prepared here what is a prime number. So a prime number is a natural number. Okay, so that is the first characteristic. 1 to 5, greater than 1. Okay, so second one is it should be greater than 1, so 2 and above. That is not a product of two smaller natural numbers. So quite similar with composite number. But this one, I'm sorry, I've interchanged it. Okay, so this one is, wait a second. This one is under a prime number. That is one. Neither prime nor composite. So it says here this one is not a prime number or not composite. But I have an incorrect example. Wait, let me see. So when we say prime number, so it should be greater than 2, and then it should have a product of two smaller numbers. This one is not a prime number anymore since this one is 1. A natural number greater than 1 that is not prime is called composite number. A natural number greater than 1 that is not prime is called a composite number. For example, 5 is prime because the only way of writing it as a product is 1 times 5 or 5 times 1. Involve 5 itself. Okay. How about composite? You just wait 1 minute. I'll just double check this one. Composite number is a positive integer. So positive integer, so 0 and above. That can be formed by multiplying two smaller positive integers, which is also 0 and above. Equivalently, it is a positive integer that has at least one divisor, other than 1 and itself. All right, so to make it quick, let me see the list of composite numbers. List of composite numbers, 1 to 100. So in composite number, we will start in 4 and above, 6, 8, 9. So 1 is not a composite numbers. This one's correct. But how about prime number? Prime, list of prime number. I think the highlighted one is a prime number. 2, 3, 5, 7, 11, and 13. So yeah, 1 is not also a prime number since in our condition here, so it should be greater than 1. Okay, so one element that is or that exists in this condition, neither prime or nor composite, is 1. Okay, which is of course a singleton set since it only contains one element. Okay. Okay, let's move on to the letter B. So we have set B, and then it has an element of a whole number, which is less than 1. Okay, whole number less than 1. So if you're going to go back and take a look on the characteristic of full number, so we've started in 0 and then onwards. Okay, so in here, where's that one? Containing an element. So x is a whole number less than 1. So the only element that is less than 1 is 0. So therefore, we could say that this one contains only one element and is a singleton set. Okay. So another example is we have here set A, wherein it has an element of natural numbers and x squared is equal to 4. So in this case, natural numbers are 1, 2, 3, 4 onwards, and then it should be equal with this one. So if you put here the natural number 1, let's say it should be equal to the other side. And as you can see, there's only one number that is equal with this one or with this condition, which is what? What, guys? What is the number that fits in here in this
2,
condition?
sir.
So we only have 2. So other than that, is not possible anymore. Okay, so this is it can actually contain two possible elements if this one is only an integer. Okay, we could say that this one is -2 or +2, but since this one is natural number and it will only consider 1, 2, 3, 4, 5 onwards, then therefore this is only number 2. So here A is a singleton set because there is only one element, 2, whose square is 4. Okay. So last example, we have here set B, wherein x is an even prime number. Okay, so again, here's the definition of prime number. So it should be a natural number greater than 1 that should have, where is that one? That is not a product of 2, that it should have at least 3, okay, product of that number. So of course, other than 1 and then other than itself. Okay, so in here, just list all the possible even prime numbers and then get Okay, an even number. So if you're going to list all of that one, I think you will only get this one. So here B is a singleton set because there is only one prime number which is even, which is 2. So other than that, the rest are odd numbers already. Okay, so in here we only have 2. So therefore, letter set B is a singleton. So, okay. So any questions so far regarding with singleton set? So this one is very straightforward. So singleton meanings it contains only one element. Any clarification so far? Where is the part that is quite confusing? So maybe at least 70%, the one that is having the main role in making you confused is the condition. Okay, so if you don't know the prime number, if you don't know a composite number, then you're doomed. So you should know the meaning of those. Okay? Because if not, you won't be able to answer. So what are those numbers and what are those list of numbers? Okay, something like that. Okay. So for you to be able to identify whether this one is really a singleton set, you should know what is a prime number and then a composite number. Okay. Any clarification so far? So guys, you guys still there? So what are your thoughts? Magulo ba?
Slightly.
Alright, so check ko lang. Mamaya wala kayo dyan. So Miss Karil, are you there? Just
Yes,
respond.
sir.
Right. Miss Patricia.
Yes, sir.
Okay, Mr. Michael.
Sir.
Okay, Miss Krisa. Miss Krisa? I think salita siya pero di ko narinig. Anyway. Miss Ashley, so of course you're there. I can see your forehead. Mr. Elijah.
Yes, sir.
Mr. Diong An. I think he's not there. Mr. Wakat. Nandyan siya. Okay. Mr. Wakat. Mr. Marvin M. Peralta. Mr. Prince. Miss Cario.
Yes, sir.
Alright. Mr. Kenneth.
Sir.
Mr. Brincher.
Sir.
Mr. Jibe.
Sir, present.
Mr. Mike.
Sir.
Miss Marbeline Carias. Alright, so some of you didn't respond. So hindi ko alam kung yung 4 na yun or 5 yun is nandito talaga. Right, so what are your thoughts regarding with empty set or singleton set? So very straightforward naman sila when we say empty set doesn't contain any element. And say singleton set, it only contains one element. So actually, ito yung isa sa mga pinakamahirap alamin if this one is really a singleton set or no. So lalo na kapag hindi mo alam yung definition of prime number and then a composite number. Okay? So don't worry. Very open na libro yung internet natin. So you can always ask Mr. Google what is a prime number, what are the list of prime numbers, what are the list of composite numbers, and so on and so forth. Okay. All right, so moving on. So I hope that you guys get the concept of empty set and then singleton set so far. So next one is finite set. So this one is super easy to understand. When you say finite, you can count the elements inside of that set. Okay, so it is a set which contains a definite number. So meaning you can define the number or the numbers or the counts of numbers of that set, okay? Or the counts of elements in that set. So we call that one finite. So empty set is also called a finite set, since we could say that it contains nothing, okay? You can count it. Like for example, here we have x is an element of natural numbers. So what are the natural numbers again? So it is starting from 1 onwards. Okay, so x is less than 7. So what are those numbers? X less than 7, which is natural numbers. What are those, guys?
1, 2, 3, 4, 5, 6, sir.
Yes. Ay dyan, sobrang simple na nga lang. Don't tell me na nako-confuse kayo dito sa symbol na to. This one is less than and the other one is greater than. So I hope hindi kayo nako-confuse, no? So sa mga ganitong condition, dapat alam nyo kung ano ba to, greater than 7 ba or less than 7. So this one is 1, 2, 3, 4, 5, 6. Okay? And then for the next set, so we have 2, 3, 5, 7, 11, 13, 17, up to 97. So this one is odd numbers. Okay? So kahit hanggang 100 pen, kahit hanggang 1,000 or 1 million, as long as you can count the elements inside of that set, then that is still a finite set. Pero if you remove this one, let's say onwards, doesn't add, so that one is not a finite set anymore, since infinite na siya. Okay, wala na siyang limit. Doesn't have a boundary anymore. Okay, so that is one way for you to identify whether this one is a finite set or no. Okay, so moving on, of course, if we have a finite, we have infinite set. So it is a set whose elements cannot be listed. So meaning you cannot really contain everything in that set because it's unending, okay, or never ending. Okay, so for example, for all points in a plane, so we have here an set A wherein it contains an element of natural numbers. And then when say natural numbers, it is ranging from 1 onwards. Okay, and in here, x is greater than 1. So as you can see, 2 onwards is under set A. Okay, and as you can see, it doesn't have an ending point. So it just continuously grow and grow and grow and grow, or continuously counting. So meaning this one is an infinite set, okay? Because it doesn't end, or you cannot definitely tell how many elements that is inside of that set. And then also set of all prime numbers, okay? So this one is also an infinite set. So note, all infinite sets cannot be expressed in roster form, okay? Because if it's in roster form, meaning it has a boundary, okay? So which will become a finite set already. All right. So moving on, we have here cardinal number of a set. So when you see cardinal, as I have mentioned a while ago, it is the count of elements, or the count of distinct elements inside of that set. Okay, so here's the definition. So the number of distinct elements in a given set A is called the cardinal number of A. It is denoted by n and then closing up in parentheses and then the name of the set, which is A. So for example, we have here set A wherein it contains an elements of natural numbers, okay? And then x is less than 5. So in here we could say that the elements of this set A is 1, 2, 3, 4. And as you can see, we can count it as it is. So this is the first element, second, third, and fourth. Okay, so if you're going to count the count of elements or number of cardinality, so 1, 2, 3, 4. So the cardinal numbers of set A is 4. Okay, so another example. So B is set of letters in the word algebra. So from here, you can count it already. So 1, 2, 3, 4, 5, 6, 7. So from here, oops, sorry. So see, I've got also fooled by this count of literal letters. So again, in set, there should be no repeated value or repeated character. So as you can see right here, A is repeated twice. So therefore, you can remove the other A. Okay, so instead of having a count of 7 elements, so in here we only have 6. So A, L, G, E, B, R. So we have a total of 6 elements, or a number of cardinality of set B, which is equal to 6. Okay, so I repeat, when we say cardinal number, it is a distinct, okay, elements inside of that set. Okay, so I hope you've got the concept of this one. Moving on, we have equivalent sets. Okay, so take note on this one, equivalent and then equal sets. So those two are not the same. So for equivalent sets, so let's say two sets A and B are said to be equivalent if their cardinal number is the same. So meaning the count of elements of this set is the same with the counts of elements of the other set. Okay, so what we're trying to compare is the count of elements or count of distinct elements, not the elements inside of it. Okay, so the symbol of equivalent set is this one. So an arrow going to the right, arrow going to the left. So vice versa. So for example, we have here 1, 2, 3 as an element of set A, and then PQR as an element of set B. So if you're going to take a look on this one, it has a cardinality of 3, and then the other one has a cardinality of 3. So therefore, we could say that A is equivalent to set B. So again, I repeat, in equivalent set, what we're trying to compare is the count of elements, not the element itself. Okay? So as long as the count of elements is the same, then they are already equivalent. Okay? So moving on, we have here the equal set. So in equal set, this one is now the one that we're talking about. So when you say equal, they should have the same elements. Okay? No matter what is the arrangement, because in set, it doesn't matter. So in equal set, two sets A and B are said to be equal if they contain the same elements. So every element of A is an element of B, and every element of B is an element of A, or vice versa. And here, as you can see, we have PQRS, and then we have PSRQ. Okay, so as you can see, all of the elements of A is also the elements of B, or vice versa. All of the elements of B is also the elements of A. So in here, we could say that A is equal to B, or B is equal to A. Okay, so equivalent set, you're going to compare the count of elements. For equal set, you're comparing the elements itself, okay, or the characteristics of element. So moving on, we have here universal set. Okay, so what is universal set? So it is the set of all elements under consideration. So take note, the special keyword for universal is letter U. So R for real numbers, N for natural numbers, Z for integers, Q for rational numbers, and then U is for universal set. Okay, so all other sets are subset of the universal set. So imagine that universal set is like the universe itself, and then the sets are the planets. Okay, like the Earth. What else? The Pluto, Mars, Saturn, and so on and so forth. So those are the sets. And that, of course, they have elements inside of it. So we have here an example. So given U has a set of 1, 2, 3, 4, 5, 6, 7, 8, 9. And then below U, okay, we have set A and then set B. So set A contains 1, 2, 5, 6 as an element. And then 3, 9 for set B. So below is a Venn diagram to represent these sets. So just imagine that a universal set is a box, okay, wherein of course it still has a boundary. But that box is very wide, wherein it can contain as many set as can. So this one, as you can see, we have here the set A, set P, and then the 1, 2, 3, 4, 5, 6, 7, 8, 9, where that is not on set E and set B. Okay, so therefore, we could see that 7 is in here, 8 is here, and then 4 is here, since we cannot find it on set E and set B. Okay, so when we say it's in a set, it belongs to a set already. But if it's not in a set, okay, then it's anywhere in the middle of the universe or the universal set, which is like this one, 7, 8, and 4. Okay, so you can think of a universal set as a big picture. Okay, it includes everything under consideration or everything that is relevant to the problem you have. So in example above, or in example on the left side, A is the subset of U, B is also a subset of U. So note that subsets A and B do not overlap. Okay, so they should be separated, or you can clearly see the difference between the two. Okay, or in other words, those sets are disjoint, so or not connected. Okay, so that's it for universal set. So, oops. All right, so I wasn't able to remove this one. This one should be removed. Anyway, so we will discuss this one later on the part 2. Okay. So anyway, we've already discussed this last meeting, subset and then proper subset. So this is just a recall. Okay. All right, so if you don't have a question anymore, so you can now leave and then just wait 5 to 7 minutes, since I need to convert this pre-recorded video. But if you have a question or clarification, you still have 1 minute to ask. Okay, is there anyone who has a question or clarification so far? Question, guys, or clarification? None?
Sir, yung due date,
Due date of what?
sir, ngayon po lahat yun?
Yung
Yung
nakaraan?
mga, yes po, sir. Pero yung may bago pa rin po kasi.
I see. Okay, so just message me in Facebook or sa Canvas, pwede naman, para malaman ko kung hindi mo pa natapos, na basta sabihin mo lang yung valid reason. Okay, and then I give you extension.
Yes po, sir. Thank you.
All right, so I think we now only have 20 seconds.